Welcome. We're here today to talk about the steel rule, typically used in machining. What's different about it, other than that it's made of steel? Well, it's not a ruler. We don't call these a steel ruler. They are a steel rule. Ruler's great for paper, for drawing, things like that. It's not particularly accurate measuring device by any stretch. Tape measure, great for woodworking, great for things where you need some length. It has this little tab on the end so that if you hook onto something it gives you the correct reading, or if you push up against something it gives you the correct reading. But that's really not something we're going to use in machining. Steel rules, on the other hand, are typically around 6 inches. They don't vary much. They're meant to make an observational measurement of something. And they come in all different grades. I can tell you right now from looking at this one, this is a very cheap steel rule, and although it does have a little bit more information on the back here, you'll see that it is set to measure things in 16ths and 32nds of an inch. Well, that's not really tenths or hundredths of an inch, so I would toss that one out pretty quick. This one looks a little better, looks like it wants to do a little more for you, but it too is set to measure either 32nds or 64ths of an inch, and it has a little conversion on the back here to tell you what that is the equivalent to in hundredths or thousandths of an inch. Again, not so great. And this, while it is a better rule, is still not a top quality rule. This one will give you 32nds and 64ths of an inch on one side, and will give you tenths and hundredths on this side, which is really what we're looking for in a steel rule. It's something that's going to measure in tenths or hundredths. It gets harder to see if it's not a really well-made rule. The number of divisions that are laid out on the steel rule are called its discrimination. And that's okay. So what makes a really good steel rule? Well, it's nice if it has some springiness to it and you can actually flex it and it will come back into shape. But if it's not made of a really good high quality spring steel, there's no guarantee that it will actually return back to perfectly straight. And my having bent that a little bit may have affected its overall wordiness as a measuring tool. Also, the way that they put this numbering on here is very important. If it's just put on with a silk screen, it's basically painted on, there's no guarantee that it's really an accurate device. Ideally, with a good steel rule, these lines are actually etched or carved into the metal in some way. A really high quality one, they use a gear to set the spacing for these so that it's always precisely placed on this rule. In modern times they will actually use a photo etchant from a master to etch into the metal, and then it's often painted after that. You should really be able to read this numbering clearly, and it's tough with this thin a rule, but this is a nice pocket size. Ultimately, it's better if it's fatter like this. You can see all the little graduations and the numbers a lot better, and that's important. Because you want to be able to read these really fine marks on here without having to break out a magnifying glass or a microscope to see what's on there. Alright, so let's talk a little bit more about these and how we're going to actually use them. Alright, so we want to make a measurement using the steel rule. It would seem smart almost to just lie this down and look across the part like so. But gee, it's really hard to tell if you've got that edge perfectly squared up or not. And gee, did we really get that right? It's just not the right way to do it. You really want to stand this up on edge so that you can peer down the lines. You also want to take this out to the 1 inch mark here, and you want to line that up on the edge as close as you can and then come over to the other side and read the line on there. It is the correct way to do it. You also want to make sure that your rule is straight, that it doesn't have a bend in it or something. This one is not perfect, but for the sakes of this demonstration here, this is going to be good enough. So we would read this here. Now it's important to understand that you don't want your eye to come from an angle one way or the other. If you do that and not look at it perfectly straight on, you'll get what's called parallax error. Your eye will actually see a different line than the true line that you would see if you were looking straight on. So you want to be careful to read that as straight on as possible. Come over and look at the 1 straight on, hold it, come over and look at your measurement line straight on. If you have a reading that is between 2 lines, try not to guess one way or the other with it, or try to round up or down. That's called interpolation, and that is not the correct way to do things. You really want to go with the lower mark, the lesser reading each time, unless you're so close to the next line that it's pretty much a dead giveaway. But you also have to let people know that you made that reading using a steel rule and not a precision instrument like a caliper or micrometer. You also should know a little bit about reading these scales. When we talk about tenths, we're talking about tenths of an inch, and you see 1, 2, 3, 4, 5, 6, 7, 8, 9, and then an inch. With hundredths, we actually have those same tenths in large scribe here, and then all the smaller ones are your hundredths of an inch. And the correct way to read a tenth of an inch, for instance, that you see right here, is to say that you have this in thousandths of an inch. In machining terms, we want to read everything out as thousandths of an inch. So if you're reading a tenth of an inch here, we actually say that that is 100 thousandths of an inch. 2 tenths be 200 thousandths of an inch, etc., using all these numbers here. If you need to read something up against a hard stop, like one of these sides, then we can actually take the steel rule right up against it, and we can use this as a reference point to make our measurement. Same thing with the depth. You don't want to hold it this way. Again, you want to hold it square to the thing that you are going to read. You should always be using an edge each time. You can bend this around something very carefully, but it helps if you buy a bendable steel rule for that. Most of these are meant to stay rigid so that they read very squarely across the item that you're trying to read. If it has a slight bend in it, you're going to get an inaccuracy in your reading. Lastly, I just want to talk about the care of this item a little bit. You want to keep this clean. You might want to keep a very light oil on it. You want to keep it as straight as possible. You should be looking each time to see if it has any bends in it before you decide to use it for a measurement. It can be a high quality tool if you care for it, and if you spend good money on a steel rule, you will get a very high quality steel rule. You can spend $30 on a 6-inch steel rule, or you can spend $3 to $5 on it, and you get what you pay for. It'll be a lot easier to read the numbers on a high quality steel rule, and you'll get greater discrimination on its face. And it should have 2 faces so that you have fractional and decimal. Alright, I hope this was helpful for you. Enjoy the rest of your day.